So now we'll do the sorting part of our code. So I've created a class called sort of generic type t, and we're going to sort our values instead of search for them. So we can mix up the numbers perhaps and set them to like random ones. And it'll put them in order. So we can delete this stuff here, and we'll come back to that after. So here we'll just do the first one, which is a selection sort. So again, I think most of these are recursive, and some of them will be using the same method again, the swap method and stuff, so we'll just work with it. So we'll have some doc here, sorts the specified array of integers using the selection sort algorithm. Add param data the array to be sorted. So here we'll have public static of type t extends comparable again. Of type t, and close the first one. Whoops, extends. Then it'll return, actually it'll return void. Then we'll call it selection sort, and it'll just take a t array data. So we'll say int min t temp. So object reference variables right now they're set to 0 and null, I think, and then we'll have a for loop here. We'll say int index equals to 0, index is less than data, minus 1, index plus plus. So index less than data dot length minus 1. So the array data dot length minus 1. I'll just set those like that to make it easy. So make sure you know how to do a for loop, of course. I'm assuming you guys already know this stuff. But if you don't know, you can use the debugger to step through it. So it's just going to have a range between 0 and the last index, which is going to be 5 indexes for us. Well, 0 to 4. Total number is 5, index 0 to 4. So we'll have we'll have min pointing to index equals index. Then we'll have a nested for loop here. I don't think this is recursive. We'll say int scan equals to index plus 1. Scan is less than data dot length. Scan is less than data dot length. Scan plus plus. If data of array index scan dot compared to data of min is less than 0, min points to scan. We're not going to go through all these, by the way, because it's going to take too long. Maybe we can do this one, just as a test. We haven't done the swap method it's telling us. So there's about 6 of these, and with the swap method there's going to be 7 codes. It's quite a bit. We're going to be doing this for a while. I might have to do 2 parts. Actually, there's a radix sort as well. Yeah, this is probably take a while to just write these out. It's going to take at least a few hours, so we'll write the swap method then. Excuse me. Like I said, these are kind of boring. They're just good practice. So here we'll have swap. So yeah, with the Java doc it'll definitely take a while. So swap 2 elements in the array used by various sorting algorithms. At param data, the array in which the elements are swapped. At param index 1, the index of the first element to be swapped. At param index 2, the index of the second element to be swapped. So swaps 2 elements in an array used by various sorting algorithms. So we're going to be using it a few times. Index 1 is a param. Index of the first element to be swapped, and then index 2 is the second element to be swapped. So it's a support method, it's a private method. Private static. Type T extends comparable of type T. Just think of this as the T here. This whole thing is just the T. Actually, let me put one more. So this whole thing is the T right there. Just think of it like that. That whole thing is just like a T there. But instead we're putting that whole thing in there and closing it with that last one. It's kind of confusing because it has 2 angulars here and then only 1 here, but that last one is really, it's over here. So that's why this whole thing is just substituted for something. So then it's a void return type. It's called swap. Takes T array data, int index 1 and int index 2. It's telling me to update IntelliJ. We'll skip that for now. So here we'll have T10 points to data of index 1. Data of index 1 points to data of index, whoops. So T10 points to data of index 1. Data of index 1 points to data of index 2. Data of index 2 points to 10. That's it. So T10 points to, so T10 equals data of index 1. T10 equals the data of array index 1. Data of array index 1 equals data of array index 2. Data of array index 2 equals 10. So that should be it. Next one, insertions. Actually, yeah, so we're done this one, by the way. Selection sort. It should be pretty easy. I mean, we can test one of them just for fun after. So we'll do the next one. Insertion sort. So we don't really need to do the doc, it just says the same thing, uses the insertion sort. What does this one say above? Yeah, so just that we don't really need to do docs for these, it's just not even explaining anything. So here we'll just say public static of T extends comparable. You can just memorize that. And then put void insertion sort. Takes T array data, that's it. Then we'll say for int index equals 1. Index is less than data.length. Index plus plus. T key points to data of index. So it's good practice with arrays at least. In position points to index. And then here we'll shift larger values to the right, while position is greater than 0, and data of array index position minus 1 dot compare to key is greater than 0. Data of array index position points to data of array index position minus 1. Position minus minus. Data of position minus key equal points to key. So that should be it. So I'll just double check. Public static T extends comparable of type T void insertion sort takes T array data as a parameter. For index equals to 1, index is less than data.length index plus plus. T key points to data of index, array index index. T key points to data of array index index. In position points to index. So while position is greater than 0 and data of position minus 1, data of array index position minus 1 dot compare to key is greater than 0, data of position array index position points to data of array index position minus 1, position decrements by 1 minus minus, data of position points to key. So that should be correct. So we know how to compare to, we just did an example of that. If position is greater than 0 and data of array index position minus 1. So maybe we can go through these, the non-recursive ones, because the recursive ones just take too long. So now we'll do bubble sort, I believe. I thought bubble sort was recursive, maybe not. So we'll go over what they are in another video. I'll try to post that one before this. I got right at this point I have like 20 videos to post, and each of them, some of them have like 2 to 3 parts, some of them even have maybe 4 parts. So there's a lot of files to work with right now, so I'm gonna try to post them. I'll try to post one today, but I'm gonna go for one a week right now, minimum. So we'll do the bubble sort one. And I don't know like how other YouTubers do it, but I never hear them like after lunch you may hear me burp. So I apologize for that. But I never hear that like in other videos. I don't know if they edit those out or just don't burp. They probably edit it out if they do. Or sneeze, like sometimes I sneeze or like I yawn. So I don't really have time to edit those, I apologize. If they do, maybe they just don't sneeze, they're just like super people. Okay, now so we'll do the bubble sort method. So we'll do public static of t extends comparable. So t extends comparable of type t, close it. It's a void again. Then bubble sort takes t array data. So we'll have int position and int scan, t temp, then for position points to data dot length -1. Position is greater than equal to 0. Position minus 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 minus. I thought it said 1, but that's fine. Then we'll say scan equals to 0. Scan is less than or equal to position -1. Scan plus plus. Then if data of array index scan dot compare to data of scan +1 square bracket parentheses and is greater than 0 parentheses, then swap data and scan, and then scan +1. That should be it. In position, what's with that? Oh, that's a comparable, of course, okay. In position, scan, t-temp. Sometimes I find it better just to write in scan on another line, but maybe sometimes you have like hundreds of variables, so you want to just keep them all of the same type. It's kind of hard though, because you still have to scroll across, so like what's the point really? So t-temp, for position, points to data dot length -1, position is greater than or equal to 0, position minus minus for scan is equal to 0, scan is less than or equal to position -1, scan plus plus. If data of array index scan dot compare to data of array index scan +1 is greater than 0, swap data scan and scan +1, so it should be right. Okay, so the quick sort not sure exactly what's happening here, but there is, okay, so it's an overloaded method. So quick sort it's a recursive method, and it looks like it's overloaded as well. So why do they write the overloaded part first? So let's try to not do that. So let's go with okay, so this is a longer one. How many go all left? 1, 2, 3. We got a radix sort too. Okay, so we got quick sort, which has a few parts to it. I guess we'll just do it the way they wrote it, which is, it's dumb. They always do the overloaded part first, which I don't really like. So here we'll have public static of t extends comparable of type t, void quick sort, takes t array data as a parameter. So all it's going to do is call quick sort data 0, data length -1. So I think they do this just to confuse people that are learning. Like, if you're learning this, you'd be like, okay, well, why are they calling quicksort with these parameters when this one only takes one? And you're trying to figure out, and you scroll down, or you flip the page, and then it's like, okay, there's another one here, another method. So it'll say private, static, t extends comparable. I think that did confuse me the first time too. T extends comparable. Of type T. Void quicksort. Takes a T array data. Takes an int min and an int max. So data, int min, and int max. Private static, T extends comparable. So they have it on 2 lines like this. 1 line works better for me. 2 lines can be confusing. But you know, you can just type code without never even entering a space. You can put that like that, and you can put that like that, and it'll still work, I think. But it's really confusing, of course, if you're not used to it. So I think in JavaScript it's more natural to do that. Personally, I'll probably write it like this, like C2. It's easier for me to space it out and read it. But you can do it however you want. So here we'll just put if min is less than max. Then here we'll create partitions. I don't really know what partitions means. So there's another method at the bottom called partition, so we'll just do this for now. So int partition, part tit shin data min max parameters. We'll space it, I guess. So then sort the left partition lower values. Let's call this quicksort. Okay, so it's the recursive. This is the recursive part. Data min index of partition partition -1. So quicksort data min index of partition -1. It's asking what it is. So here we'll have sort the right partition higher values. Here we'll call quicksort index of partition +1 and max. So it's gonna be I think it's gonna call all of them. So it's gonna do them in order. So it's gonna be like this recursive one method and then this recursive one. So it could take a while again. And we'll do the partition part. So private static of T extends comparable of type T int partition takes T array data int min and int max. So here, partition element, kind of a long word, int left, right, int middle equals to min plus max divided by 2. Then here it says use the middle data value as the partition element. Partition element points to data middle. What happened there? Swap data middle and min. We'll say left equals to min, and then right equals to max. That should be right. It's kind of a long bit there. Should be correct. Private static t extends comparable type t takes t array data int min int max t partition element int left right int middle, which is just the midpoint. Partition element points to data middle. Swap data middle min. Left points to min, right points to max. Okay, that one's fine. Private static t extends comparable void quicksort. T array data int min int max. If min is less than max, int index of. Yeah, I think I got is this the index? It had a error here. Index of partition points to partition data min max as parameters. Quicksort data min index of position -1. Then quicksort data index of partition +1 max. Should be right. Then here we have quicksort data 0 data dot length -1. That's it. Then we just have merge sort and radix sort. Okay, so merge sort is another long one. And I think it's another private kind of style method. I think merge sort was the longest one actually. That's the one that took me like 2 hours to do. Do we do this one? In partition? No, I think we missed some stuff, unfortunately. Because it went to the next page I didn't see. Okay, so in partition, right equals to max. So we have some more stuff here. Honestly, I think I can just try to copy it in. It's kind of a lot of stuff. Don't think we need one bracket though. So right equals to max. Actually, we don't need both of these brackets. One of them we. Okay, so maybe I'll just continue. Right equals to max. Actually, no, that's fine. We'll just try pasting it in. Okay, maybe that's a little confusing because something happened here, so let's not do that. Let's take this out. Actually, no. Let's move it way down. Then let's take that. Try pasting that in. It did work. We can just type it out though, because it might be a little confusing. So we'll just say while left Actually, we don't even need to space that, so we can say while left is less than right. So there's a comment on it, we don't really need to do that, so we'll just say while left is less than right and data of array index left dot compare to partition element is less than or equal to 0, left plus plus. So these are like while loops in while loops without brackets. So while data of array index right dot compare to partition element is greater than 0, right minus minus, then if left is less than right, swap data left and right. That should be a semicolon. I don't know why it's formatting it like this. So while left is left than right, then while left is less than right and data of array index left dot compare to partition element is less than or equal to 0, left plus plus, then while data of array index right dot compare to partition element is greater than 0, right minus minus, if left is less than right, swap data left right. And outside that bracket, we'll do swap data min and right, then return right. So I'm sorry, unfortunately, I don't think we're going to be going through this one. I mean, they're all, you can go through them. I think I've shown you how to do a recursive method, but that one only had maybe 2 or 3 passes. Some of them have like 8 passes, which are all in each other, and like a few other ones, so it could be hard. That's going to take way too long to do. So hopefully you can step through it in the debugger. I've showed you how to step through and just write recursive pass here and do the stuff I showed you. It's going to help. So there's 2 more here. One's another longer one. So we'll bring these brackets up here, and then we'll do our next one. So public static of t extends comparable of type t void merge sort takes t array data. So it's going to call itself with an overloaded call, I guess. I'm not really sure why they set it up like this. So takes data 0, data.length minus 1, data 0, and then data.length minus 1. So merge sort, data 0, and data.length minus 1. It's asking it, the reason why it's underlined, it doesn't know where to get those parameters from, because right now it only knows a merge sort with 1 parameter, so it can't find one with 3 parameters. So under that, we'll say private static, private static of t extends comparable of type t. void merge sort takes t-array data, int min and int max. So if min is less than max, then we'll say int mid points to min plus max divided by 2. Merge sort data min mid. Merge sort data mid plus 1. Max, so there's a lot of recursion going on here. Then merge, I don't think we've written that method yet. Data min, mid, and max. Okay, so merge is a long one. So under this we'll write, I know you're excited for the long methods that are just math and arrays, but we'll, since you're so excited, we'll just do it now. So public static of generic type t extends comparable of type t called void merge, and this one takes 4 parameters. T-array data, int first, int mid, int last. T-array temp points to casted T-array to new comparable dot length, so I guess it's a comparable array. That should have a capital C, because we can't create a T-array again, so we have to suppress warnings here. We don't have to, but we should. So add suppress warnings unchecked. So I'll have int first 1 points to first, last 1 points to mid. So int first 1 equals to first, and then another instantiation, last 1 points to mid. I don't think it really likes that, to be honest. It's saying, I think it's not liking this at all. Yeah, I don't think it liked the way, either that's an error or it just doesn't like that at all. So int first 1 points to first, comma, last 1 points to mid. Okay, now it works. Did I do something? I'm not sure what I did wrong there. We'll say int first 2. Personally, I don't like instantiating stuff like that. Last 2 points to last. You can change it to the other way. So if you're going to do that, why not just put them all in one line then? But I guess this programmer wanted to do it that way, so then we'll say int index points to first 1. Whoops. Not sure what that was, so we'll say while again. Okay, so while first one is less than or equal to last one, and then first two is less than or equal to last two. If data of array index first one dot compare to data of array index first two is less than or equal to, so just less than 0, then temp of array index points to data of first. First one plus plus, else temp of array index points to data of first two. No, we needed some brackets there. Index plus plus. Then a no, wow, that's an okay, another one. Another, like, 3. So if data of first one, that blocks in the else. The index plus plus, and then we'll have a while falling asleep here. First one is less than or equal to last one. Temp of array index points to data first one plus plus index plus plus. Then for index points to first, index is less than or equal to last, index plus plus, data of array index points to temp of index. Okay, that's it. Check it. I'll check it for you to make sure it works. TRA temp points to TRA new comparable data dot length. In first one, first, last one points to mid. In first two, mid plus 1, last 2 points to last. Index points to first one. Well, first one is less than or equal to last one, and first two is less than or equal to last two. If data of array index first one dot compare to data of array index first two. There's an error here. There should be a bracket, parentheses I mean. It's less than 0. Temp of array index points to data of first. I'm just gonna have some water while I do this. So first 1 plus plus, else temp of index points to data of first 2, index plus plus, while first 1 is less than or equal to last 1, temp of array index points to data of first 1, array index first 1 plus plus, index plus plus. Okay, something's wrong here, which isn't good. I think we missed a loop. While first one is less than last one, if else. Well, first one is less than or equal to last one temp of array index equals to data of first array index first one plus plus index plus plus. Yeah, so we missed a loop in here, so we'll go under here, say while first two is less than or equal to last two temp of array index points to data of our index first two plus plus index plus plus. Then under that, for index points to first index is less than or equal to last index plus plus data of array index points to temp of array index. So that should be correct. How many brackets at the end? Just one. And that's the one for our class. That should be it. We just have one more. And honestly, I don't think we really need to test these. I mean, it's just straightforward stuff. We've covered the same compared to stuff in the searching video. It's the same idea. We're just saying, okay, is this one greater than that one? And if the data of array, this index, whatever that number, let's say position is 2, then 2 minus 1, so array index, data of array index 1, which is, let's say, holding the value 2, dot compared to, let's say that the key is like 10. Since 2 is not greater than 10, then this would be false. So it's just stuff like that. It's pretty easy stuff. Nothing too hard, except for the recursion. Maybe arrays if you don't know. But arrays is just, you're just storing a value in brackets. It's nothing too hard, right? It has an index. We've done videos on that. So there is one more. It's a radix sort. And I think we'll take a break and come back.